you need or you require some other instrument in order to what I can say, in order to make the circuit breaker operate. So these are the two major disadvantages of using HVDC system. Okay. So we have discussed about the advantages of using HVDC system and disadvantages of using HVDC system. Do you have any queries regarding this? Anyone has any question regarding this matter? Hello?
স্যার তাহলে ডিসির ক্ষেত্রে যে সার্কিট ব্রেকারগুলো ইউজ হয় ওটা মানে কি প্রিন্সিপালে কাজ করে?
ওইটা হচ্ছে তোমার force, you have to use some other instrument where it can force down the current should force down to the zero value so that circuit breaker can work actually. Okay, current should be zero, otherwise your circuit breaker, it is quite difficult to operate the circuit breaker. Is that okay?
Yes sir.
Okay.
জিরো ক্রসিং বলতে কি স্যার এখানে হচ্ছে যে এসির কেসে হচ্ছে ওই যে কোনো একটা যে ফেজেরই মানে স্যার যে কারেন্টটা ওই জিরো ক্রসিং করলে মানে তখন ইউজ করতে পারছি, তাই তো? মানে ওটা যে ডিসি ক্ষেত্রে পসিবল না।
এক্স্যাক্টলি। তুমি if you can remember the principle of the circuit breaker, how the circuit breaker operates actually. Circuit breaker actually there are two contacts, one is fixed contacts, another one is moving contacts. When the current becomes zero, then the moving contacts start to operate actually. And
okay sir.
But in case of DC, if you see the HVDC system, that as the current is not crossing zero, so it is quite difficult to operate the circuit breaker if any faults occur. That's why you have to bring the current to zero, then you can operate the circuit breaker. That's why it is said that the current should come zero or current is brought down to zero forcefully, then the circuit breaker operates. Is that clear?
Okay sir, clear.
Okay. Any other question? No. Okay. Now coming to that most important part of our courses is that insulators. Okay. Now I think you have seen the insulators. So let's start to discussing about it. As I mentioned in our last class that we generally transmit the power using two major systems. One is overhead transmission line, using overhead transmission line. Another one is underground cable. Okay. Now I think you have seen that overhead transmission line. If you can remember the overhead transmission line system, there are transmission line, and these transmission lines are supported by some tower, because you have seen that this transmission line is hanged from the tower. Okay, and this tower is grounded actually. So there is a cross arm in the tower, and between the cross arm and the transmission line there is a instrument, you can say, which is known as the insulator. The insulator is generally can be porcelain type insulator, can be glass type insulator, can be polymer type insulator. So its material can be different, and this type of insulator can be used based on that in which application you are using. Okay. Now while we are discussing about the insulators, the most important thing of the insulator is to calculate its creepest distance. Now let's try to understand what does this insulator do. If you consider the transmission line tower structure, okay, now tower has a potential zero because it is grounded. Okay, now from tower there is a cross arm, and from cross arm the insulators are there, and from insulator the transmission lines are hanged. Okay, so you can say the potential at the cross arm is zero because it is connected to the tower, and the potential of the transmission line you can say it is a high voltage line, so it has a very high potential. So the function of the insulator is to protect the transmission line from being short circuited with the tower, or alternately you can say it actually prevents any breakdown or flashover occur between the medium within the tower and the transmission line. So this is the function of that insulator. Now, you know, if you can see any insulator, have you seen any insulator? First of all, in our laboratory, anyone has seen the insulator in our laboratory?
Yes, sir, in high voltage lab.
Yes, sir.
Yes,
Yes, sir. High voltage lab.
yes. So you have seen the insulators. If you can remember the geometry of the insulator, it is not a simple structure. Okay, there is a curvature inside the insulator. Okay, and these curvatures actually is intentionally made in order to enhance the path between the live conductor or the conductor and the cross-arm point, and this path is known as the Creepest distance. Okay, if we can see the picture, you can see this is the schematic of the insulator. Okay, there is an earth pin, so it is connected to the cross arm, and here there is a groove where a high voltage conductor is placed. Okay, now if you see the schematic of this insulator, you can see the insulators are curvy. The geometry of the insulators are so simple, and this is done in order to increase the path between that earth pin and the HV conductor, and this path is known as the Creepest distance. Okay, generally what happens if any breakdown occurs between or if any problem occurs between the HV conductor and the earth pin, generally what happens, the breakdown occurs through this path. That means the breakdowns occurs in this region. So if you increase the length of the Creepest distance, okay, then there is a less probability the breakdown will be occur between the HV conductor and the earth pin. Okay, now in this Creepest distance there is a portion, if you can see this portion, there is a portion where these portions are not exposed to the, you can say, rain, because when the rain occurs, this portion can be exposed, but these portions are not exposed to that rain, and these portions which are not exposed to that rain is known as the protected Creepest distance. So how this protected Creepest distance is measured? Generally, in order to measure the protected Creepest distance, we generally put some light, okay, at the maximum angle of 90 degree, and we generally try to identify in which portion the light is not coming. Okay, so if you throw the light in you can say the perpendicular with that earth pin, you can see these portions, the light will not come. Okay, and so these portions are known as the protected Creepest distance. And typically you can say typically the insulators looks like it is a pin insulator. You can say this is the earth pin and there is a groove, so you can say this portion is known as that Creepest distance, and the inside of this is known as that protected Creepest distance. Okay, now there are, as I mentioned, there are two most important things you have to know while you are discussing about the insulator. One is flashover voltage, another one is puncture voltage. Now coming to that, what is flashover voltage? Flashover voltage is that voltage at which a spark occurs, okay, through the insulator surface, or you can say through the Creepest distance. Okay, and then this voltage is known as the flashover voltage. So flashover voltage, what is it? So flashover voltage, a spark occur, okay, through the Creepest distance between the live conductor and earth pin. So at which voltage it is occurring, this voltage is known as the flashover voltage. And this flashover voltage is most critical thing in case of insulators. Because you know, the flashover occurs due to the breakdown of the air. Because you can imagine, if you can see the insulators, so insulators are placed like that. So you can see adjacent to that insulator there is air. So what happens if somehow, for some reason, if the breakdown of air between that light conductor and earth pin has occurred, then you can say that there is a flashover occurring in that insulator. And one interesting thing is that this flashover is not a permanent. Okay, because you know, in case of air insulation, when the breakdowns occurs in case of air insulation, temporarily there will be a breakdown. But what happens if the voltage is reduced, then the insulating property of air is restored. So you can say flashover of the insulator is not a permanent one. Okay, but what happens if the flashover is repeated? So what happens? There is a path, you can say path created through the surface of the insulator or through the creepest distance of that insulator. Okay, through the tracking. Okay, and that may actually enhance the probability of the flashover on the insulator surface. So you have to be very cautious while you are just monitoring the insulators. Just if the flashover occurs repeatedly, then what happens? A permanent sign, or you can say a tracking sign, is you can see on the insulator surface, and that tracking path will help to break down the air at low voltage. Okay, so that may harm the insulators. Now this is the flashover voltage. Now another one is the puncture. Puncture is what? Puncture is the breakdown through the internal, you can say breakdown of the insulators internally. That means if you consider the insulators, here the high voltage lines are there, here is the earth pin. So if the breakdown occurs through the internal of that insulators, then you can say it is the puncture has occurred in case of insulators. Okay. Generally, if puncture in the insulators is occur, that insulators cannot be restored. That means you can't use that insulators. That's why you have to be very cautious that in case of insulators, puncture should not occur. Okay. Flashover may occur. That is not a problem because its insulating property may be restored after the flashover. But in any case, if the puncture occur in case of insulator, then you can't use that insulator anymore. So that's why generally what we do, we generally prepare, or you can say we generally manufacture the insulator in such a way that its puncture voltage should be higher than the flashover voltage, so that in any accidental case, flashover can occur, but the puncture should not be occur. Is that okay? Hello?
Yes.
Okay.
এক্সকিউজ মি স্যার স্যার পাংচারে কি স্যার এই মাঝ স্যার ওই ছবিটাই স্যার একটু স্যার স্যার পাংচারে কি ওই হাই ভোল্টেজ কন্ডাক্টর আর্থ পিনটা কি মাঝামাঝি দিয়ে ভিতর দিয়ে কি কিছু হয়ে যাবে মানে ভিতর
Exactly. It will, the breakdown will actually, you can say it will be the breakdown of insulators material. Actually, if you consider the porcelain insulators, the puncture means the insulators porcelain insulator will be breakdown. That means the breakdown will occur through the porcelain insulators. But if you consider flashover, it is
বাইরে দিয়ে পাত ক্রিপেজ পাত দিয়ে
exactly through the surface of that insulators.
Yes sir, thank you.
Okay.
Yes.
That's why your puncture voltage should be higher than the flashover voltage. Okay.
বাট স্যার এগুলোকে স্যার যে পাওয়ার ট্রান্সমিশন লাইনে হচ্ছে যে ইনস্টল করার আগে এই মানে এগুলো স্যার যে ক্যালকুলেট করবো কিভাবে, মানে স্যার যে ভোল্টেজ গুলো, মানে যে পাংচার ভোল্টেজটা যে বেশি হতে হবে এই ভোল্টেজের থেকে, তো
তার জন্য
এগুলোকে
বিভিন্ন
মানে
রকম
কি
টেস্ট
টেস্ট?
করা হয়। ইউ হ্যাভ টু
হ্যাঁ,
টেস্ট ইট, ইউ হ্যাভ টু টেস্ট ইট অ্যাকচুয়ালি,
আচ্ছা, হ্যাঁ
টেস্ট ইট।
yes, sir.
Otherwise, how can you determine? And generally, what we do? We
মানে কোনো
first,
ম্যাথমেটিক্যাল ক্যালকুলেশন আছে না?
no. Actually, definitely, you have to design first, and based on the resistivity of that porcelain insulator, you and dimensions of the insulator, you can calculate how much should be the breakdown voltage of that insulators. If you consider that porcelain material, okay, and you know that you can measure the creepest distance, so you know the breakdown voltage of air. So based on that creepest distance, you can get an idea what should be the flashover voltage of that insulators. Okay, so based on that you can calculate actually.
Okay.
You can say who are designing this, they can say, or they can say that whether how much is the puncture voltage, how much is the flashover voltage for a particular insulators.
Okay, sir.
Is it clear? Okay. Now we have discussed about the flashover voltage. So flashover voltage means generally flashover occurs between the earth pin and the HV conductor. One interesting thing I just need to mention is that we have seen in case of insulator, there is a earth pin, there is a HV conductor. Okay. So you can say through the creepest distance, or you can say through the surface of the insulators, if you calculate, there should be some resistance, because it is you can get some surface resistance. Now while there is a transmission line actually, so there is some voltage in the transmission line. Due to the voltage, a portion of current, you can say a fraction of current, will flow through the surface of the insulator during healthy condition. If there is no problem at all, the lines are operating safely, at that condition you can say, as the insulator through the insulator surface, a portion of current is flowing between HV conductor and the earth pin, and this current is known as the leakage current. So in case of insulators, this leakage current is most important, because how much fine you can design an insulators, in spite of that, there is some leakage current present through the surface of the insulator. Now this magnitude is very low, because if the magnitude is high, then definitely there is a problem, because as the magnitude is increasing, so you can understand there will be a local heating through which the current is flowing, and as the local heating is occurring, so what will happen? The air you can say more number of charges will be developed. That means more electron will be produced, and that can lead to the flashover. So limiting the leakage current is most important thing. You should not allow the leakage current to increase beyond a certain limit. Okay, and that is the most important thing. But the problem is that as you have seen that the insulators are installed at the outstation. That means it is, you can say, it is not installed in the indoor place. It is installed at the outstation. So you can say generally where you have installed the insulators, the dust can deposit on the insulator surface. Besides, there may be rain. So rain means there is a water particle can deposit on the insulator surface. Okay, one second. Please be patient. I have some problem. Sorry for interruption. Okay, I have some power cut in my area, so yeah, that's the problem. Yeah, what I was talking about. Hello, am I audible to you?
Yes, sir.
Yes, sir.
Okay, sorry for the interruption. Yeah, that I was talking about. Leakage current is the most important thing. So what happens if you consider the insulators actually, which are installed to the outdoor station? What happens? There might be a rain. So as you know, if there is a water droplet deposits on the insulator surface, the leakage current increases. Okay. So, and as the leakage magnitude of the leakage current increases, so what will happen? There is a high chances the flashover will occur through the surface of the insulator. So there are, you can say, there are various factors which actually affects the flashover voltage of that. You can say flashover voltage of that insulator surface or insulators. So you have to just consider this factor while you are designing the insulators. Okay. Now from this figure you can say when the leakage current flows through the path as indicated by A. So it follows the path of A. But sometimes what happens when the flashover occurs? Now flashover can occur in two conditions. One is dry flashover, another one is wet flashover. And you know the dry flashover actually is occur through the path as you can say indicated by B, whereas wet flashover is indicated by C. And it is interesting is that wet flashover path is lower than the dry flashover path. Okay. Now, what are the insulating material are used for, or what are the materials used for manufacture the insulators? There are, as I mentioned, there are three types of material can be used for manufacturing the insulators. One is you can say porcelain. Porcelain is used for manufacturing the insulators. Glass can be used for manufacturing the insulators. And number three is the polymer. That means the rubber. Rubber can also be used for manufacturing the insulators. Generally, we use in case of overhead transmission line, you can see we generally use porcelain insulators or toughened glass insulators. Okay. So for glass insulator, while we are constructing the glass insulators, generally the glasses are heated around 720 degrees centigrade. Okay. And once it is heated, next it is cooled down rapidly. So once you cool down, what happens? There will be a compressive force developed inside the insulators, and this compressive force is balanced by the tensile stresses on the body of the glasses, and that actually improves the mechanical as well as the thermal property. Now coming to that, advantages of using toughened glass over porcelain insulators. First one is that toughened glass has greater mechanical strength if you compare with the porcelain insulator. Number two is that it has high thermal shock resistance. Okay. And number three is that toughened glass has greater puncture strength. Okay. That means the puncture voltage of the toughened glass is higher. Okay. And number four is that the life of the that means you can say the operating life of the toughened glass is higher than the porcelain insulators. Okay. Is that okay?
স্যার থার্মাল শক মানেটা কি?
High thermal shock resistance. That means if your temperature actually increases, what happens? You can say, as I mentioned, when the current is flowing through the surface of that insulators, then what happens? The temperature across the insulator surface is increased. Okay. And that may reduce the resistance through the surface of that insulators. So you can say that enhancement of the temperature can reduce the surface resistance, and that resistance is known as the thermal shock resistance. Is that okay?
Yes, sir.
Okay. Now, coming to that, as I was mentioning, the type of insulator, you have already aware of that. There may be different type of insulator based on how we are just placing the conductor. So based on that, we generally know there are 4 type of insulators actually. First one is that pin insulator. Pin insulator, you have already seen the figure of the pin insulator. Okay, so pin insulator, you have already seen pin insulator. In pin insulator, the lower portion there is a metal rod, so which is connected to the cross arm, and at the upper portion there is a groove through which a transmission line conductor actually passes. So this is the pin insulator. But besides pin insulator, there is another type of insulator which are known as the disc insulator. In disc insulator, the construction are little bit different. In that disc insulator, generally conductors are hanged from the insulator. Okay, and the upper portion is connected to the cross arm. And number 3 is that suspension insulator. Suspension insulator means there are number of disc insulator connected in series. It depends on how much is the operating voltage. That means if you consider the high voltage transmission line, your voltage level can be 132 kV, sometimes you can say 300 kV, etc., etc. So how much your voltage level, based on that you can design the suspension insulator. And number 4 is strain insulator. Sometimes what happens, you need a sharp bend of the transmission line. In that case, you can use that strain insulator. So we will discuss one by one. First one is the pin insulator. As I have already mentioned, pin insulator is supported by a pin or bolt. That means there is a metal iron or metal rod which supports the weight of that insulators. Okay, and at the top portion there is a groove through which the transmission line passes. Okay, the disadvantage, or you can say the characteristics of pin insulator, is that you cannot combine multiple pin insulator in series. So you can understand it has some operating limit. That means you can't use the pin insulator beyond a certain voltage level. So generally what happens, we generally use this pin insulator up to 33 kV. Beyond 33 kV, it is not economical for us to use that pin insulator. Okay, so this is the typical structure that I have already shown you, the pin insulator. Okay, now coming to the disc insulator. As I already mentioned, the structure of the disc insulator is little bit different. So you can say unlike pin insulator, the upper portion of the disc insulator is connected to the cross arm of the tower. Okay, and you can say this is the LV electrode, means this LV electrode is connected to the cross arm, whereas that you can see the HV electrode through which the transmission line actually passes. And you can see this is the creepest distance. Okay, and generally the height becomes varies from 16 centimeter to 18 centimeter, and diameter becomes 28 to 29 centimeter. So generally what happens, we generally design the disc insulator for withstanding a voltage of 11 kV. So if you require to use for higher voltage, you can connect this disc insulator in series for operating at higher voltage. So this is the typical figure of the disc insulator you can see. So there, the lower metallic portion, this means this portion is you can say high voltage electrode, and the upper thick metallic portion is connected to the a cross-arm structure of the tower. Suspension insulators characteristics.
Hello, sir.
Yeah, tell me.
স্যার এখানে স্যার যে ডিস্ক ইনসুলেটরের ক্ষেত্রে আপনি যেটা বললেন ওই 11 কিলো ভোল্টের জন্য ওদের একটা হাইট দেওয়া আছে। এবার যদি স্যার যে 44 কিলো ভোল্টের জন্য আমি ইউজ করি হচ্ছে ওই চারটে, তাহলে যে সিরিজে ইউজ করব মানে এইভাবে রিলেশনটা না অন্য কিছু দেখতে হবে?
না, চারটে না, তোমাকে একটা ইয়ে রাখতে হবে, টলারেন্স ব্যান্ড রাখতে হবে, টলারেন্স লিমিট রাখতে হবে। চারটে জায়গায় তুমি পাঁচটা ইউজ করতে পারো, ঠিক আছে? ধরো 11 কেবির জন্য যদি আমি একটা রাখি, চারটে বা চারটে থেকে পাঁচটা, সেটা ডিপেন্ডস অন দ্যাট টলারেন্স, হাউ মাচ ভোল্টেজ ফ্লাকচুয়েট অ্যাকচুয়ালি। সো ইয়া, চারটে থেকে পাঁচটা in series, and that is known as the you can say string insulator actually. So number of insulators connected in series, string insulator.
Okay sir.
So as I mentioned, beyond 33 kV we generally use suspension insulators. Okay, and as you can see, if we want to use the string insulator disc insulator for 132 kV or 232 kV to 230 kV lines, then you can use around 11 to 13 disc, where 230 kV you require 18 to 20 disc. Okay, so that is your suspension insulator. Second. Now coming to the typical schematic of the suspension insulator. So you can say this is the suspension insulators, number of insulators when they are connected in series, you can say. So this is the tower structure, typical tower structure, grounded tower, and you can say these are the suspension insulators. Okay. So this is the actual real figure of the suspension insulator. You can see, so number of disc insulator are connected in series. Now, what are the advantages of using this suspension insulator? Okay, first of all, these insulators are designed generally for 11 kV. So if you want to use for higher voltage, you can connect in series. But the most important thing is that if you would have used a single unit, you have to design number of spare parts for different voltage level. Likewise, I am telling that suppose you are going to use the insulator for 33 kV. So you can design an insulator based on the 33 kV. But sometimes what happens, you require to use an insulator for suppose another voltage like 66 kV. So in that case, you have to use or you have to manufacture another insulator which can withstand at 66 kV. But the advantages of using this suspension insulator is that for 33 kV, you can use 3 or 4 units. But for 66 kV, you can use 6 or 7 units. So you don't need to manufacture 2 different insulators. You just can put some spare units. Okay, and based on your voltage requirement, you can connect or you can add these insulators in series so that it can withstand that much of voltage. So this is one advantage. Number 2 is that instead of using suspension insulator, if you would have used a single unit, and if there is some defect in that single unit, then you have to change it, and you need to bring a new one, and that may include a vast cost actually, you can say. But in case of suspension insulators, if any units are defective, then what you can do, you can just simply change that unit. Okay, so that is the another thing, another advantage. Number 3 is that mechanical flexibility. If you use single unit, there is the mechanical flexibility of using single unit is less. But if you use suspension insulators, it has greater mechanical flexibility. So these are the advantages of using suspension insulators. Okay. Now coming to the strain insulators. As I mentioned, suppose your transmission line requires a sharp bend. That means suppose sometimes it requires around 90-degree bend. Okay. Or you can say if there is a terminal, in that case we use generally strain insulators. You can say it's like there is a jumper. Okay, so you can say from the figure, so HV line is coming here. Now there is a sharp bend. Okay, and so HV line is going out from that tower. So there is a sharp bend. So in that case, we can use that strain insulators. Okay. So the actual figure of the strain insulator looks like that. So you can understand. This is the strain insulator. Now coming to the post insulator. Post insulator, what is post insulator? Sometimes
স্যার স্ট্রেন ইনসুলেটর স্যার ওই জাম্পারটা কি বলেন স্যার, একটু জাম্পারটা দেখাবেন ওই ছবিটা?
হ্যাঁ one second. Yeah.
স্যার এটা একটু বলবেন স্যার আরেকবার, একটু জাম্পারের পোরশনটা মানে
কোনটা?
মানে স্ট্রেন ইনসুলেটর বলছেন কার্ভড, মানে কার্ভড কিছুর জন্য ব্যবহার হয়, কিন্তু এই জাম্পারের ব্যাপারটা কি?
Look, so there is a towers, you can say in the tower, suppose a transmission line has come from the east side. Just try to understand. Okay, and again it will go to the south side. So there is a 90-degree bend because it is coming from the east side and it is going to the south side. So you can say when it is coming from the east side, so it will end it to the tower. Again from the tower there will be another transmission line which it will go to the south side. So but there should not be an electrical disconnection. That means there should be electrical continuity between the line coming from east side and going out to the south side. And in order to connect that, we generally use jumper. That means there is a wire, you can say, which connect between the two lines, and this is the jumper actually. Is it clear now?
Yes sir, yes sir.
Okay, it is nothing but the connective wire between the two lines actually, you can say. Okay. Now coming to the post insulator. Post insulator is what? Sometimes you know what I can say, in substation, I think substation, you have seen the substation, there are certain instruments that is used but it is not mounted actually, you can say. Okay, certain thing in that case, but you can't put it on the ground because you know ground has zero potential. So you can't put that instrument on the ground, but according to our application it should not be mounted to some other places. So in that case there is an insulator which is used to separate out between the instrument and the ground. That means the instrument are placed on that insulator, and these insulators are known as the post insulator. You can see the figure of that post insulator. So it is an insulator on which the instrument can be placed. And this post insulator, there is a corona sheet. I think you have some idea about the corona. Corona means, you know, the corona. when there is a transmission line voltage,
collision
the
ionization,
atmosphere, atmosphere surrounding to that transmission line get ionized. Okay, and definitely there will be a hissing sound, violet color, etc., etc. But do you know why this corona occurs actually? This is due to the high electric field intensity adjacent to that transmission line.
rough surface.
And due to this,
Yes, sir.
yeah. So high electric field intensity. Now, if you consider the post insulator, you can see another thing. Just I would like to mention that if you consider the parallel plate, generally parallel plate configuration, you can see the electric field intensity is constant. Okay, but if there is some you can say the sharp edges, if there is some point, then you can say their electric field intensity becomes high. Okay, and as the electric field intensity is high, the insulation will get stressed higher. Okay, so in order to avoid that, generally we use different type of shield so that the electric field intensity value get distributed, electric field in that means potential get distributed and electric field intensity value becomes lower. In case of post insulator, as you can see in the figure, there is a surface. Okay, and due to the surface, there is the electric field intensity at that surface is quite high. Okay, and that can result a breakdown of air between that you can say upper portion of that instrument between the instrument and the ground. So in order to avoid that, we use a corona shield. What happens at corona shield? Actually, if you look the actual view picture of that corona shield, it is a circular type. So what happens as it is a circular, the field distribution due to this corona shield gets, or you can say it moves towards the uniform. So the electric field intensity becomes more uniform with the presence of corona shield. So that can reduce, or that reduces the chances of breakdown of air. Okay. Now, so actual post insulator looks like that. Okay. Okay. Now coming to that, another thing is that shackle insulator. One second. Shackle insulator, actually, let's see the shackle insulator. Yeah, shackle insulator looks like that. It acts like a you can say where you need to bend the transmission line actually. Then we use shackle insulators. Okay, it's like a you can say when there is a terminal, then your transmission line should change its direction. Then we use generally shackle insulators. So this is the typical look of that shackle insulators. Coming to that voltage distribution of suspension insulators, so that I will cover in the next day. So today is up to shackle insulator. So if you have any question, then you may ask me.
স্যার এখানে যে কোনো ইনসুলেটর কি ওই টাফেন গ্লাস বা পলিমার দিয়ে তৈরি হতে পারে? কারণ সবগুলোই তো মনে হয় মোটামুটি
না,
পোর্সেলেন।
তুমি না সবগুলো করতে পারবে না। You can't create shackle insulators or post insulator using polymer. Okay, generally toughen glass and in porcelain insulator, you can your post insulator and shackle insulator can be polymer, can be toughen glass or porcelain, but it is quite difficult to manufacture a post insulator using this polymer insulators, the polymer material actually. Okay.
Yes, sir.
Any other question?
হ্যালো স্যার মাঝে হ্যালো স্যার
হ্যাঁ, বলো।
ওই হচ্ছে যে ইনসুলেটর প্রোফাইলটা কি ওই মাঝের একটা স্লাইডে দেখলাম মনে হয় ওটা মিস করে আছে
না, ওইটা তোমাদের দরকার নেই, আমি ওটা বলছি। এক সেকেন্ড। হ্যাঁ, এক সেকেন্ড। ইনসুলেটর প্রোফাইল দেখতে পাচ্ছ, স্ক্রিন দেখতে পাচ্ছ?
নো স্যার
No, sir.
One second. দেখতে পাচ্ছ এবার?
Yes, sir.
হ্যাঁ, ইনসুলেটর প্রোফাইল হচ্ছে, সেটা হচ্ছে ধরো তুমি যদি একটা ইনসুলেটর কনসিডার করো, ধরো আমি ধরে নিচ্ছি তুমি একটা পিন ইনসুলেটর কনসিডার করছো। পিন ইনসুলেটর ধর কনসিডার করছো। এবার ইনসুলেটর প্রোফাইল হচ্ছে যদি তুমি পোটেনশিয়াল দেখো থ্রু দ্য সারফেস, ওকে, জেনারেলি সেগুলোকে কি রাখা হয়, আমরা ইকুইপোটেনশিয়াল, মানে ডিজাইনটা এমন ভাবে করা হয় যাতে আমরা যখন একটা কার্ভ, ইফ উই ড্র এ কার্ভ থ্রু দ্য সারফেস অফ দ্যাট ইনসুলেটর, through the curve the potential should remain same. Okay, that means the potential profile as, and you know, if the lines are equipotential, so electric field intensity lines are perpendicular to that equipotential line. So in this diagram you can say, in this diagram, yeah, you can say these are the equipotential lines, these are the equipotential lines, and these are the field lines. So in insulator profile we generally identify how the field lines are actually originates and how they actually, how the electric field lines becomes or perpendicular to that equipotential line, and you can say how the equipotential lines are there on the insulator surface, and that is actually identified using the insulator's profile. Is it clear? So you can see these are the body of the insulators, so these are the insulator equipotential lines, and these are the field lines. That is the insulator profile. Is it clear?
Clear, sir.
Any other question? Okay. So that's all for today. So I will take the next class on today's 18th. So I will next Monday, Shobhan sir will take the class. So next 25th. So I will take next Tuesday class on next Tuesday. Okay.
Okay, sir.
Arunim Poddar.
Present, sir.